Disclaimer, there's gonna be a lot of math in this video. Just embrace for it. Okay, let's get started.
In this video, we're going to solve the in-circle problem and make it more difficult and difficult and difficult. Basically, just make it to the point that my brain becomes smush and just unsolvable. I have not seen any video or any Wikipedia page about the in-circle problem, but let's just start with a triangle and see if we can solve it. The in-circle problem is just figuring a way out to somehow get a big circle inside of the center. So look at that, but obviously it just needs to fit in there. So let's just solve it. Let's get that right over with. We got a triangle and okay, let's get the midpoint. All right, now we just need to get a line. So hopefully we get some sort of center. Okay, I don't know why he's doing that. Anyway, so we got a center and hopefully, okay, I don't think it can even possibly fit. All right, so instead of finding the halfway point of this line, what we can possibly do is somehow have like a halfway point on the angle, I think. Yeah, might as well do that. What we can do is that since this is in the center, what we can do is get the segment line right here and get the perpendicular line, because it's the opposite, through here. And look at that, we found the angle. All right, so since that we figured a way out to somehow find the midpoint of this angle, we just have to do the same thing in the other side. So let me get the circle, get a line, and get the perpendicular line of this. And look at that, we find an intersection. So let me put that out and let me see if I can get the circle. Okay. Wait a second. Okay, let's get the particular line of this one because I saw a 90 degree. And so let me get the circle. Oh, look at that. We solved the in-circle problem. Now, here's the question. How can we make this a little bit difficult? Let me just reset. Get that. Stay on the... Wait. Why can I not refresh? Okay, there we go. We refreshed. Okay, look at that. Now we just have to make this problem a little bit more harder. So let me get this. Get the lines to make the triangle. Bam, bam, pow. And let's get back and see how we can make this a little bit difficult. So instead of the way that we did it before by putting a segment and then getting the perpendicular line like this, what we can do is somehow figure a way out to get a line intersecting somewhere instead of being at here. Okay, so what we can do, see if I can imagine this in a box. Okay, so instead that these two sides are similar, what we can do is have the perpendicular line of here, 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 and what we can do is project it outwards. Okay, and have, oh, look at that. So we got a point from here, and what we can do is intersect from here, getting the perpendicular line of here, solving for the halfway point. Okay, let's do that. Let me just get a line. There we go. Okay. Oh, wow. Look at that. It worked. Now I just had to get a line passing through. So if this is the halfway point, it must pass through this dot right there. So let's see. Oh, look at that. We did it. We don't need this point. We could just get the two sides without using that point. Okay, that worked. And now we just have to do the same thing on the other side. Let me just color this black. I can actually see. Let me just zoom back in here. Now, the way I did it was get a circle, get a segment from here, get a segment from here, get a segment from here. What we can do is get the perpendicular line from here, here, and here, and here. Let me just get that right there. And since that they have two intersections, what we can do is plot those 2 points down, like that as so. And when this line goes passing through, so let me make the line. It intersects right here, so let me get the point. And what we need to do is to get the perpendicular line of this line. So let me just get right here to here. And since we don't need this point anymore, what we can do is get the line that intersects from here, all the way intersects from here. And since that this dot is just the center, it will get passed through. If I zoom out, we don't need the others, we don't need this side because we got already an intersection from here. So let's spot that out. And now we can do the same thing as before, get the perpendicular line from here to the center and bring out the circle. Okay, there we go. Wow. It reminds me of like some sort of opening like a circle. What? That's very trippy. There's a lot of lines. Okay, so now we have to make this a little bit difficult. Now, the challenge here is to somehow get only one circle. Okay, let me just drink because talking is very dehydrating. And when you talk so much, water just tastes so good. Okay, so we just need one circle to solve this problem. Okay. Okay, how? We get the perpendicular line from here. What we can instead do is make our own triangle. Okay, let me just do that again. Okay, there we go. We got an intersection from here. What we can do is get a line, and now we have a triangle. We look like this. Okay, so what I can do is hide this. Like that. Look at that. We got a triangle right here. We don't need that point, but let me just bring it back just in case. If I can do that. Okay, we brought it back. I don't know what was going on. But now, okay. Oh, look at that. Oh, wait a second. Oh, wow. Wait a sec. Wait, let me... Okay, we can hide this, and hide this, and it already automatically had the halfway angle. So that means what we just need to do is get the perpendicular line from here, get the circle. Okay. Yo, wait a second. Oh, we did it. Oh, we did it. We already. Oh, wow. Okay, so okay, we solved it. Now let me just. Huh. That's interesting. Okay, so we already solved that. Let me just explore and see what happens if I add a circle here. Okay. Oh, well, that's cool. That's the center right here. Okay. So let me get the particular line of one of these sides. Okay. Hide. Whoa. Okay. Particular line from here. This looks very familiar. Hide. What? Let me hide that. Let me just hide all this stuff right here. Are you seeing what I'm seeing right now? This looks very, very familiar. Whoa. Okay. So if I have the lines passing, okay. Oh. Yo. Let me just hide whatever that is. Yo. That looks very familiar. Okay, so we've kind of discovered something that I never knew that I never knew that. That's kind of let me just hide all this junk. I don't know why I'm seeing all this stuff. But yeah, that is very bizarre. I never Okay, so we did that. Now, since that we've figured that out, now we just make it difficult. Okay, so obviously this is geometry. Let's get into math. Yeah, we're gonna make this a little bit more difficult. So let's get ahead of geometry. We're going to math. We're gonna make this a little bit more difficult. Let me just do that. Okay, how are we gonna do this? Well, since that we know how to do it geometrically, we can just do the same exact thing with math. Just mathematics. That's great. Move this, move that. Okay, that looks good. That looks like a triangle. What we can do is get lines like that, like just like a line intersect. So I'm gonna just get the equation out. Okay, we got one. What we can do is copy this 2 times, flip that. Okay, and then remove this, and put it 2, and there we go. We got that. We got a triangle. All right. Now, like as we did before, we put a circle. Well, let's get a circle. Yeah, that is a circle. And what we're gonna do is get the parentheses of that. We move over to like some point. Why not? I think it's any of these 3 points. Okay, we got that. Let's get the other point. 1, 1. Like that is so. So I'm just gonna look at these. Okay, so now we got circles. Now what we need to do is figure out the intersection between the circle and the line. So this line right here goes here, and this line goes here. Okay, so now we got 2 intersections, and that means what we need to do is solve for x. Okay, great. We need to solve for x. Okay, well, I'm going to just time lapse 3, 2, 1. Okay, there we go. We got it. So now, since we have the intersections with this line and the circle, what we can do is, well, just get the line, and then there we go. We solved for y. Look at that. It's right there. And what we can do is make this as a point, so we can know where that point is. And now we just do the same thing with this one right here. So let me get the line right here. Get this. Oh, okay, now we're going to put this as a point. Okay, look at that. We did it. So now what we need to do is make a line that goes through here. So let me get these 2 points right here. I'm going to remove this so we won't get distracted. And now we just do the same thing like how we did with these lines. Now we just have to do with this. So let me just bring this over here, divide, minus, minus, get this, and add with the y. So it's going to be add with the y, move over with the x, like that is so. And what we're going to do is get the x, and we're going to get the y, and we're going to do the same exact thing the other side. Okay, look at that. We got a line. Okay, since that we got the line, what we just need to do is get the perpendicular line and then put it to this red dot right there. So I'm just going to put this over here. Let's put that as power of -1 and put a negative right there. And what we're going to do is remove this because we don't need it anymore. Why? Because we want to move it to red, and red is x and y. So just put x and put y. And look at that. We figured out the half point without using cost functions. Great. Now we just have to do the same thing with this side right here. Okay, yeah. And there we go. We found the intersections, and since this is slope, we can turn this as slope intersect. So that means we go over here, we copy this down so we know where we're going. And now what we just need to do is equal these 2 slope functions together. So let's just do that. Okay, there and there. Great. Now we just have to solve for x. Since this is going to be simple, what we need to do is, well, move over y. That's in the back. Pretty lonely y. I don't know why. Okay, now we got this. We need to do is move over my bro. He's pretty hefty. And since that there's a negative in front of him, we're just going to put an addition sign right there. Now, since that we can do is get this. We're going to distribute. Great. This is going to be addition sign. All the way over here is going to be a subtraction sign. So it's going to leave like that. And what we're going to do is move to the back. The same exact thing. We distribute, get through them like this, like this. We zoom out so we can see, obviously, we want to see the entire thing. And since that we distributed with everything, now we just need to do is, well, move over this. Yeah. We're moving this over, and what we're going to do is put an addition side, put a parentheses, like this as so. We're moving this entire thing to the other side. So we're going to go all the way over here, put a minus, there we go. And what we're going to do is just get rid of the x's, because the x's are being multiplied, or parentheses over here. Now what we're going to do is divide the entire thing like that. Great. Now if we zoom in, we can see if the answer looks real. Okay, the answers look real for real for real, and that's it. That's the entire equation to solve for x. Obviously, it looks, let me zoom out. Yeah, he's a very small boy. Anyway, now what we can do is get this x, and then we put an intersection through here. So let's get this. Okay, we got Mr. This. We're bringing this down, and we're zoom out again and get this x. We get this, and there we go. We solve for y. Let's turn this as a point, get this as a comma or whatever, and get parentheses, and there we go. We found the intersection to this. Okay, so, oh, look at that. It looks really nice. What we need to do is, since that we figure out the point, now we need to figure out the way to put a circle in here. So let me just remove the distractions, because I don't like distractions. Okay, so we need a circle. We're going to bring the circle up here. Get that. Look at that as so. Equal 1. And now what we need to do is, since that we need to move the circle to this red dot. That sounds simple enough. Let me put the parentheses. This get over here. There we go. We got parentheses right here. Okay, copy this and move over. Okay, there we go. Now, obviously, there's a problem. It's a very dumb problem, and we need to figure out the radius, because obviously the radius is not 1. What we need to do is like the same thing as before. We need a perpendicular line. We can just choose this one. Scroll all the way down, get this. We're going to get a power of -1. Put this as a negative right here, and then we're just moving this over to the red dot, so... Yeah, all right. I don't know why I'm laughing. This is weird. There we go. We're gonna get this. We're gonna get this. Where's Y? Your Y, stop hiding. I know you want to be this. All right, there we go. Now, since that we have the perpendicular line, I don't know which one looks perpendicular. Okay, that looks pretty perpendicular. We're gonna just change the color so I can actually see what it is. And now what we need to do is find the distance between these two. So that means we need to find the intersection with this line to this line. So let's get this line right here. All right, there we go. And what we need to do is solve for x, because we need to solve for this point. So let's zoom out a little bit so we can copy the entire thing. Actually, we don't need to do that. We can put a parentheses. There we go. Look at that. Looks pretty hefty. We're going to copy this. We're going to put it as equal sign right there. And look at that. Now we just have to solve for x. Great. Okay, so now let me see if I can find x. Where are you? Oh, x is right here. Look at that. It's great. Apparently, I couldn't find him. He's very small. Anyway, what we're going to do is remove these parentheses. Oh, dinner? Okay, I'm back. Sorry for the lunch break. Alright, so did my mouse just die? Connect. Okay, there we go. Man, my mouse is not ready. Maybe that mouse came from pharmacy. Alright, so let me just move over the Y, of course. Yeah, it's kind of hard to see Y. I'm looking at Y, right? Why are you multiplied? Oh, wait, there you are. There you are. Found you. Okay, let me just move you over. Get Mr. Y. We do the same thing as before. Get the Y, move over. Then what we need to do? Okay, let me just move over. Okay, wait, let's first distribute. So we're going to distribute this. We're going to just add this and then remove the parentheses with that negative. Then now we can just bring this other x over. So look at that. Let's bring that over. Get that. Go all the way over here in the back. Play that's the back. Put a minus. There we go. It's right there. And we're going to distribute this little dude. No, big dude. He's massive. Giant. And we're going to add this together and remove the parentheses there. And since that we distributed, what we can do is move over this variable. Okay, well, they just look different. My bad. Or I couldn't tell because the sizes are very... Okay, now what we're going to do is move over this. Yep, looks good. And put a negative sign here. There we go. And we're going to do the same thing. We're going to remove the x. We're going to remove the x. Then we put a parentheses like that as so. It's like called factoring. And what we're going to do is take this and we're going to divide. No, I'm sorry. We're going to put a parentheses that over the entire thing. And there we go. We solved for it. Now, since that we solved for x, now what we need to do is choose one of these lines. Well, we can choose this line, but it wouldn't be fun. Let me just choose this line. Why not? What we're going to do is, yeah, that looks good. What we're going to do is copy this entire slope intersect, and we're going to put x into here. What's x? It's right here. And there we go. We solve for y. Now what we need to do is get this point and get the comma, get that, and get to the back. There we go. We figured out 1 point. So let me just zoom back in. Since that we already did that, what we can do is just, we use Pythagoras, and that's it. So we're going to solve the distance between these 2 points. So what we're going to do is get the square root. We're going to get our parentheses, add them together, put a minus sign, not an equal sign, minus sign. And then we're going to square them both like that. And that's where we get Pythagoras formula. Woohoo. Look at that. We can share an image. Okay, so now since that we have that, let's get our first point. We get the first point right here. Well, the big ones go to the right. So let me just go over here. Yep, there you are. I hope that's the entire thing. But whatever, hopefully that's the entire thing. All right, let's move over to the side. Let's go to the Y area. And now it's the red point's turn. Get down here. There you go. And now we go for Mr. Y. Hopefully that's Y. Yep. And what we're going to do is get to the Y area. So let's do that. And that's Y right here. Look at that. Kind of hard to catch. And what we're going to do is zoom all the way out so we can see the entire radical. And there's a radical right there. What we're going to do is copy Mr. Radical, and we're going to move over to this one right here, because that's where the circle is. And since that we don't need this radical anymore, because in the circle issue, it's squared, it's whatever. The circle squares things, so we have to remove this radical. Let me get to the, you know what, I should have just done that. So we're going to remove the radical, and look at that, we solved the problem. So let's zoom out so we can see the entire thing. Oh, I'm already zoomed out. I'm already fully zoomed out. Okay, so that was a waste of my time. Well, let's just explore. Did I delete something? I don't know what I just did. Okay, well, let's just see the entire thing. You're not that big, bud. Come on. Okay. Okay, there we go. We hit the end. At least there's an end. Let's see the parentheses. I really like seeing parentheses. Okay. Let's see how big this parenthesis is. It's probably like a pixel long or not. Okay, well, it's okay. It's okay size. Anyway, so we already finished with that problem. We've kind of overkilled it. So let me just remove this so we can get rid of the distractions. Let me get rid of the distractions. And we solved the problem. Look at that. So now, since this was a little easy, what we need to do is make it a little bit difficult. So how can we find this? How can we make this a little bit more difficult? Okay. So since that we did this geometrically, right? And we kind of copied off from geometrically, so this is kind of making it a little bit easier, but how can we make this a little bit more difficult? That's kind of a little hard. Let me just save it so if anyone wants the circle thingy. Let me just remove these lines. You can share this to your teacher if you want. Just gonna put, oh, I forgot the problem's name. In circle problem. There we go. Look at that, we save it. All right, so now, since that we've figured out that way, how can we make this a little bit more difficult? What we can do now is, well, remove all of whatever I've did, all this. All right, so we open graph, and now we have to figure a way out to make this problem a little bit harder. So instead of solving it geometrically, what if we can solve it multivariable calculus? Yes. What I mean by that is somehow figuring out, okay, I got an idea. What we're gonna do is get y. Obviously we need our 3 points so we can make a triangle. Let's do that. There we go. Look at that. And what we're gonna do is make the lines again. That would be great. So since that we're trying to make this a little bit more difficult instead of, the way we did it is, okay. So what if we somehow controlled space? What if we can somehow make space solve our problem? What I mean by that is if I remove the existence of Desmos and we look at this plane existence, well, we can imagine that all the light is every single possible way to measure something. And the solution is obviously somewhere in the center. So somewhere in the center will be the solution. what we can do is make a mapper. What I mean by that is like a little scanner that will scan through everything. I think this would work. Yeah. Anyway, so we got this little mapper that will scan through the space. And what we're going to do is instead of measure all of them, we're going to measure one single line. So this line right here, what we're going to do is say like right here, why not? It's going to project a line, so the distance of that line from this point to this point, finding your distance, will give out a number, and 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 a number. And the more of me, going through all this space, this little mapper scanning out to find the solution, and boom, somewhere right here is the solution. Okay, so what we're going to do is make Mr. Pythagoras. We're going to get Mr. Square Root. Yeah, get that. We're going to put a subtraction sign, put D and D1, get this, put a parentheses, get that, and look at that, we figured out, look at that. So let me just put this dot, yep, we see that. The reason why you see like that little area being a little bit pinchy is because I'm getting close to this line. So the mapper knows that I'm getting close to the line. So if I go somewhere around here, okay, we need to make these three functions. So let me just do that. What we're going to do is copy this 2 times and get this one there and this one there. Okay, there we go. Look at that. So that means if I put it somewhere in the center, what we can see is that all these are somewhat aligned to each other. What we need to do is somehow make them all align to actually show us the solution. So I'm just gonna, okay, yeah, obviously I'm just gonna keep on going and see if I can get closer. All right, so 0.5, okay, 0.5, 0.5. So yeah, I'm trying to figure out to make them align together. And the only way to do that is to figure out the minimum of this function. And the only way to do that is to get a ball rolling down the hill to hit the bottom. And the only way to do that is using derivatives. Yes. What derivatives are is when somewhere in this point where x intersects is a line. Like, I mean, I can show you a GIF, and that's what a derivative. It's like putting a flat piece of paper on a very curved surface and just moving along, and it looks like that. What derivatives are. And the reason why we're using derivatives is that since that we go over here, see that little area right there, that our solution, where the solution is, if I put that as a derivative, what we can see is that point. If I put y equals 0, look at that. Where did my function go? Oh yeah, forgot. I turned it as a derivative. And what we can do is see that when x is equal to 0, it intersects and also leads up to the solution. So what we can see is 2.480985, 2.480985. Yeah, like, I mean, it just does that. So what we can do is equal this to 0, and what we're going to do is basically do the same thing with all the other functions. So let me just copy these down so we can see. Yep. Get the derivative, equals, and look at that. However, obviously there's a problem because we need to solve for the derivative because we need to solve for it. And then we have to equal it to 0. So let's first solve for the derivative first. Let's solve for the derivative with all the 3 functions that we have. Okay, 3, 2, 1, go. Boom! Yeah, okay, so we figured out the derivative. It looks like this. Yep, and also I sort of solve for 0. So we can just remove these because we don't need them anymore. Look at that. And now since we already solved that, what we need to do is input these into this. And then what we're going to do later is bring this function into the 3rd dimension. So what we can do is that we need to solve for this. And the reason why we're trying to solve for that is so we can figure out how we're going to align them all together. And I'll show you later. So we're going to get this and this there, and I forgot there's another X there. Good. Now what we need to do is get this. Where's blue? Oh, it's here. We're going to get this and that. There we go. And we're going to get Mr. Green, this, and that. All right, so since that we can't visually see this in the 2 dimension, but what we're going to do is make this mapper into X and Y. So we're going to go to the 3rd dimension. Let's do that. All right, let me just get all this stuff. 3D Desmos. There we go. 3D Desmos. And we're going to just get to transfer all this together. What just happened? Oh, I moved over the tab. Let's copy this. Okay, great. Now we get all the variables out. Look at that. Let me just see our points because I can't visually see empty numbers in space. Okay, let's move over these so we can see a triangle. Oh yeah, first we had to get Mr. X and get Mr. Y. Okay, whoa. Oh, look at that. Look at that. It just shows the solution right of our faces. And also, these triangles right here, let me just remove this face. We don't need that, nor this line or this cable looking thing. Okay, look at that. You see these triangles right there? It reminds me of those circles. Oh, yeah, they do. And also it shows you the solution right here. Okay, so what we really need to do is somehow equal this function with this function and equal this function with this function and equal this function with this function. And then since that we all equal all these three spatial planes, well, let's actually do that. So let me equal this. Let me make some space. Equal this. Get that. Get this. Okay. Wow, we're getting somewhere. Equal. Oh, whoa. All right. Let me get this. Yo. Whoa. Yo, it just shows you the solution. That is crazy. Okay, so since that we figured that out, let me get this. We're moving this over. Okay. And since the mapper cannot be visualized, what we're going to do is put this X and Y, move in this. Okay, so now, yo, that is so cool. The hell just happened? I don't know what happened, and I don't want to talk about that. That was weird. Okay, so look at that. That looks, we brung space, and kind of, we're not done yet because we need to put the circle in there. So now we have to solve for X, meaning D, and we have to solve for Y, meaning D1. So let me just solve for Y first. Let me remove this because we don't need these anymore. They're useless to us. Okay, I don't think it's gonna be that hard. Problem looks very polynomial. Okay, so I guess we have to solve these. We can remove one of them because we don't need that. Okay, all right. So what we need to do is solve for Y, and when we solve for Y, these two lines right here. Let me just remove this. It's gonna be one line or like one single line, and then we can solve her as X. Okay. Let me try to see if I can solve this. I'll be right back. Don't worry, it's gonna be soon. It's been a month. And, I solved for Y. So, let me just show you what I have so far. So, since I had to solve for Y, it kind of gave me a lot of variables. However, I was able to figure out the formula, and it happened to be a quadratic formula, and I put it all together, and I was able to solve for Y. Let me just remove all this. I don't need it. That's for later. And let me remove the failed attempt. So, I realized that it was a polynomial 4, and I needed a formula. It was like the quadratic equation, but it is this. And I had to write it down to see if I can get the right solution, and none of them were the right solution at all, and I wasted a lot of time, a lot of days, a lot of variables that didn't really work out. I didn't understand why it didn't give me that one solution that I needed. I'm back, guys, and the plan worked, and I did the same thing as before. Get the particular line and put it to 0 with the circle, and find the distance of it. Let's zoom out and save the solution. So let me show you how much variables there are. So if we zoom back in, I'm gonna go all the way down. There's about 232 variables, somewhat, in this function. Isn't that great? So I'm gonna share this to see if you want it or anything, or share it to anyone that you'd like to share it to, because I think I'm done. This problem kind of got a little very difficult to me, and I kind of got lost it. But this is the space that I'm talking about solving for the distances. So if the mapper was right here, it would be red, it'd be this, but see that center right there? That's the solution right there. Obviously, you can tell that this is a 3D function, right? And I can use partial derivatives, but since that's multivariable calculus and I'm only in algebra 2, I had to learn that. And since I learned that that partial derivatives thing, it didn't work out because I guess it just didn't. Yeah, it's been very hard. Anyway, I hope you subscribe and like and share, especially share, because this kind of took me a lot of time. Anyway, exercise, eat protein. Why not? Actually, get some water. Eating protein with powder, it's not good. Anyway, see you in the next video. Anyway, bye.